All right, in this video, we're going to look at evaluating the sum, difference, product, and quotient of two functions at a particular value. So there's actually two different ways we can approach this, and depending on what you have to do and all that, one method might be preferred over another. I'll show you both methods and then pick the one you like best. So let's say again that f of x is x plus 2 and g of x is x squared minus 4. Now, f plus g of x, we could find by adding the two functions together, combining like terms, etc. Now, if we want to evaluate this at an actual value for x, so for instance, we want to evaluate this when x equals 3, one method is to plug a 3 in for f of x and plug a 3 in for g of x. So if we evaluate f of 3 and then we evaluate g of 3, we can add those two results. So f of 3 is going to be 3 plus 2, and g of 3 is going to be 3 squared minus 4. So 3 plus 2 is 5, 3 squared minus 4 is also 5, and 5 plus 5 makes 10. So one approach is to evaluate each of the functions at that value and then either add or subtract or the results or whatever it is you're doing and get your final answer. However, what we could also do is we could also first figure out what f plus g of x is. So f of x plus g of x, where we take the x plus 2 and add it to x squared minus 4, we get x squared plus x minus 2. And now if we want to evaluate f plus g of 3, we could just plug a 3 into this result, this x squared plus x minus 2. So 3 squared plus 3 minus 2 gives us 10. So really it's a matter of personal preference which method you want to use. My recommendation is if you have a bunch of problems to do. So for instance, let's say you've already figured out what f plus g of x is from a previous problem. Then if you're asked to evaluate f plus g of 3, I would just plug it into the result I got from the previous problem since you've already done that anyway. So example 2, we're going to evaluate each of the following. We're going back to f of x is x squared minus 3 and g of x is 4x plus 5. The good news is we can use, again, any of those two methods. Very helpful that we're using the exact same functions for f of x and g of x because we can also use our results from many of the problems in example 1. So first up, f plus g of 3. We could do f of 3 plus g of 3. So 3 squared minus 3 is 6. For g of 3, 4 times 3 plus 5 is 17. And then 6 and 17 makes 23. We could also have plugged in our 3 into what we got as our answer for example, I believe this is example 1a, f plus g of x, which was x squared plus 4x plus 2, and then plugging in a 3 into x squared plus 4x plus 2 should give us 23. Part B, f minus g of 0, f of 0 minus g of 0. We have 0 squared minus 3 is negative 3. 4 times 0 plus 5 is 5, so negative 3 minus 5 is negative 8. Part C, f times g of 2. We could do f of 2 times g of 2, or we could plug a 2 into our answer from f of x times g of x in the previous video. F of 2, 2 squared minus 3 gives us 1. For g of 2, 4 times 2 plus 5 gives us 13. So 1 times 13 gives us 13. Part D, g times g of 1. So we could even multiply a function by itself. And g times g of 1 means take g of 1 and multiply it by itself. When we plug a 1 in for x, for g of x, we get 4 times 1 plus 5 is 9. So 9 times 9 gives us 81. Part E, we have f over g of 1, which means take f of 1 and put it over g of 1. So 1 squared minus 3 is negative 2 for f of 1 in the numerator. And then g of 1, 4 times 1 plus 5 is 9. So we get negative 2 over 9, which we can't reduce. So that's our answer for example 2E. All right, finally, example F, we have g over f of 8. So that means plug 8 in for g, or 8 into g and for the numerator, and 8 in for x, for f of x in the denominator. So plugging in an 8 into g of x here, we get 4 times 8 plus 5 is 37. For f of 8, 8 squared minus 3 is 61, and 37 over 61 cannot be reduced, so that is our final answer. And if it could be reduced, such as like 2 over 4, we always want to reduce it and say something, give it in lowest terms as a half. But here, again, we can't, because 37 over 61 is as simple as that fraction is going to get. All right, so that about does it for this video. Thank you for watching. I'll see you next time.